In this session, we're going to consider black boxes and truth tables. A black box is a way of representing something that we can't take apart, we can't see what's inside of it, we just know that it does something. It has some input, some way of getting something into it, and something coming out of it, some outputs. And based upon what we put into it, determines what we get out of it. So we might say that the black box has a way of transforming the inputs into some output. Therefore, we're going to want a way to represent what the different combinations of outputs are. What output do we get based upon what input? And for that, we have truth tables. And in its simplest form, a truth table is going to be two columns. One of the columns on the left for inputs and columns on the right for outputs. So both of these being visual tools, we're going to want some way to draw them, and I'm going to head over to diagrams.net. Diagrams.net is an interesting website in that you'll notice there's no sign up button. There's no way to create an account or something. And so what happens is we're going to download this drawing software into our browser without having to install anything. So that's one of the first big things. We don't have to install anything, although you can download it here, install it if you want. And if you use it a lot and your drawings get bigger, it might be handy to do that, but probably for what we're doing, at least right now, it'll be fine just to use it in our browser. The second thing is, because there is no login, there's no sign up page or anything like that, and that is because we don't actually store any information on diagrams.net servers. We can store our drawings other places. So I'm going to click on Start. And it's downloading the software into my browser now, and I have a choice to I'm going to say change storage, because this is what you will see the first time you start it. Here are some options of where we can store our data to. We can store it on Google Drive, which is nice if you want to share it. We might do that later on, or you can do it now. OneDrive, if you like to use that. Device, meaning a local storage device like a hard drive or flash drive or something. That's what I'm going to do for now. GitHub. I'd probably use it in another context. But anyhow, I'm going to say I want to store this on my device, and I want to create a new diagram. So the name up here is untitled diagram.draw.io. Little trivia, diagrams.net used to be called draw.io. So you'll still see that file name extension. Regardless, I'm going to simply say that I want to call this black box. There's different templates for different types of drawings. I'm not going to be concerned about that. We just want to make some basic drawings. So I'm going to simply say create. It says, okay, where do you want to create it? I'm going to put it on my desktop. That's fine. Again, you can organize your files the way you want. After I call it something like perhaps black box. And so here's the interface. Again, you can download it if you want. What we see is on the left-hand side are some libraries of shapes. Okay? And you'll remember that I said all I want to do is create rows and columns. So I'm going to come over here, and I can either click on the line tool, and it'll throw a line in the middle of the page, or I could drag a line over. And so what I want is a horizontal line and a vertical line that cross each other. Okay. So remember I said that I'm going to have inputs on the left of this vertical line and the outputs on the right. One column for each input, one column for each output. You can have as many as you want of either ones. And then the horizontal line I'm going to use as a divider for some labels for the columns from the different states that we'll see below. Okay. So for example, I want a label. I want some text. There is a text option over here, or in diagrams.net. If you simply double click or click, it'll come up. The default element is text. And so I'm going to call this A. Okay, so here's my input A. And then I'm going to make another one, and I'm going to call that B, very creatively. And then I'm going to say, okay, I have a couple of outputs here of C and D, and then I can drag those around wherever I want, pretty things up. You'll get the hand of using diagrams.net as we do it. And so now I want to consider, okay, what are the values of the outputs that I get for certain values of inputs? And we are going to be working with binary systems, okay? And so a lot of people, if you've been in computers at all, you probably think of binary bits, ones and zeros. And I usually ask the question, like, what do computers understand? What's the most basic thing that computers understand? And one of the most common answers is ones and zeros. And I'm going to do my best to dispel that myth. Okay, because the computer does not understand what 1 or 0 is any more than it understands what my glass of water or my eye color is. It actually works on a binary system, and there's something that has two values. So let's get this out of the way first. The prefix bi, meaning two. Okay, so think of like a bicycle or bi-weekly, bi-monthly, something like that kind of thing, where in a bicycle there are two cycles, two wheels, bi-weekly meaning every 2 weeks kind of thing. And "ary" as a suffix means that there's some quality of something about it. So think of a word that ends in "ary, like perhaps imaginary. Okay, and imaginary means that there's a quality of imagining to it. So stationary means there's a quality of station or being in one place to it. So put that together, and I'm going to say that binary simply means that there is a quality of two-ness to something. So we're dealing with something that has a quality of two-ness. Okay. That could be anything you wanted. In our modern digital electronic computers, that thing is electricity, and what it works on is a difference between two values of electricity. So there's some threshold, and all it knows, if it knows anything, is that at any given point in time, there is some value of electricity, and it is either above or below a threshold. Okay. And that could be voltage or current. I can elaborate more on that in another session if you want. But suffice to say that, again, it's important, I think, to start wrapping our heads around this idea that binary means there's something that has two values. Okay. And that's all it really means in its most generic sense. So, sure, those two values could be the two quantities of 0 and 1. Zeros and ones make a binary system, that's fine. But it doesn't have to be that, and they certainly don't have to be numbers. It could be a binary system of two colors, or anything else, the system where there's two values. Okay, so the next thing that's going to come out of that then is that nothing in life is fair, it seems, and so there's two values, and we're going to have to prefer one of them. One of them we're going to pick as being our preferred value. Again, if you stop to think about it, if you've done much with computers and this idea of ones and zeros makes sense to you kind of thing, then you'll probably realize that you probably have a tendency to prefer the ones over the zeros. In other words, you look at the ones more than you look at the zeros kind of thing. And that's all I'm saying is that whatever the two values are, we're going to look at the outputs. We're going to look at the results in terms with respect to one of those values. Okay? So I'm going to use preferred and other. Now I need some way to represent those, so I'm going to use P for preferred and O for other. the preferred value in the other. Because again, it's not that I don't like or one of the values. I really like one, I don't like the other. It's just I prefer one. And that's what I look with respect to. The other one's perfectly fine. It's okay. They're both okay. But I have a preference for one. My perspective is focused on one of them. Okay, so that means then I could come over here and I could say, I'm going to use a P to say that I have a preferred value. And maybe I stick that into my input A. And then I have an other value. And I'm going to stick that into B, input B. And the question becomes, okay, if I have a black box, some type of black box that has 2 inputs and 2 outputs, they're labeled A and B for the inputs. I put a P preferred into the A input and an other value, the other binary value, into the B input. What comes out of the C? What is the value of the output C? Now again, it can only be preferred or other. Those are the only 2 values we have because it's a binary system. There are 2 and only 2 values. So you choose. I'm going to say that I get an other out of C. Okay. And then I'm going to say, well, what do we get out of D? And I'm going to say, well, we get a preferred out of D. There we go, out of the system. Now, what does that mean? Well, that's what we're going to look at in the future of what are some meaningful combinations. But that'll give you the idea of black boxes and truth tables. For a black box, I'm going to simply draw a rectangle. Okay. And then I'm going to say that, okay, the inputs, oops, I had Control Z instead of Control C. So I'm just going to draw another rectangle here that represents my black box. Again, you can fill it in and make it blacks if you want, but I'm just making line drawings. So I'm perfectly fine with the fact that it's just a black outline filled in white, but I'm going to call it a black box. If you really wanted to, you could come over here in diagrams.net and say, oh, it's filled with black. Your preference. My preference is not to do that. So I'm actually going to hit Control Z this time to undo that. And then I'm going to come down here and I'm going to grab this label that I have of A up here and put it in the black box. But since there is a fill on the black box, it's behind there. I can either right click on this and say send it to the back. My black box, so the A is now on top of it. And I'm just also going to go ahead and turn the fill off so I don't have to deal with that again. The B here, I'm going to make a copy of it. I think I already did accidentally. No, I didn't. It's bold, looks a little bold, but okay. So Control C this time, Control V, make a copy of it. And there is my B input on the left. And so then, excuse me, I'm going to have my C output. I'm going to typically put it on the right. And I copy and paste my D. There's my black box with the labels on it. Again, I tend to put the inputs on the left or the top, and the outputs on the right or the bottom, because I'm thinking of a flow through here of, in this term, flow of left to right or top to bottom. But it really doesn't matter. And as our black boxes get more complex and we have more inputs and outputs, we'll put them in different places. The position isn't critical. Okay. There we have it. Black boxes and truth tables. What more could you possibly want to know about black boxes and truth tables? Well, we'll put them to use next time.